Hello, this is FlippedHarber for Physics. In this video, we're going to talk about Newton's three laws of motion. Now, the outline for the video, we're going to talk about Isaac Newton, his book, the Principia. I've also heard it called the Principia. I don't really care. Newton's first law, Newton's second law, and Newton's third law. Now, Isaac Newton was born December 25th, 1642. He attended the prestigious Trinity College at Cambridge in England. He is still considered by many physicists to be the single biggest contributor to science and mathematics. His most famous book, the Principia, that's actually just a shortened version of the title, which basically means that it's the philosophies of natural principles in mathematics. Now, he was the holder of the Lucasian Chair of Mathematics at Cambridge University, and that is like holding a certain office at the university, and even today it's still considered a high honor to hold that chair because Newton once held it, and the man who held it before him, last name of Lucas, was also very brilliant and very important in the fields of mathematics. Now, he did not invent the Fig Newton. That's actually named after Newton, Massachusetts. But on to our real story. In the Principia, which was published in 1687, he laid out a lot of different ideas, not just the three laws, but he talked about the motion of bodies without resistance. That is, how objects move without this force of resistance. Think about friction. In the second book of this, he talks about motion of bodies with resistance, much harder to talk about. And then in the third book of the Principia, he talks about gravity, and that's actually where he lays out what he's probably most famous for, and that's his theories on gravity. Now, Newton's three laws are found in kind of a preface to the book. It's called the axioms or laws of motion that are found at the beginning of this book. By the way, this is an image of his actual copy of the first edition, and he actually made notes in this book for corrections in the second and later editions. But let's go ahead and talk about the first law. First law simply says that an object that is at rest will remain at rest, and an object that is moving will continue to move in a straight line with a constant speed if and only if the net force acting on the object is zero. So really, this law tells us that forces cause acceleration. Okay, they cause changes in an object's velocity. Now, that may not seem very deep and profound to us, but back when he wrote it, this was actually a big deal. Every non-straight line motion was caused by forces. Okay, and you've got to think about how basically dumb a lot of people were around him. This was a big deal. Now, to really get a handle on this, think about the Voyager space probe that was launched in 1977. It's way out in space. It's not being pulled on by any planets now, really. So it's going to continue in a straight line forever and ever and ever until some force acts on it to stop it or to turn it. Maybe eventually it'll pass by a large object that will curve its path slightly, or maybe eventually it's going to slam into something. But it's going to continue moving in that straight line until a force is acting on it. Now, Newton's second law, probably the most famous law, is actually best stated in an equation. Force equals mass times acceleration. And really what this law says is that a bigger force causes a bigger acceleration on an object. So again, sticking with our convention, blue vectors are the force vectors, purple vectors are the acceleration. A big force is going to cause a big acceleration on an object. Now, also from this law, we can figure out the standard unit for the force. If you take 1 kilogram of mass and multiply it by 1 meter per second squared of acceleration, that's what we refer to as 1 Newton of force. Newton did not come up with that name. We decided to name it in his honor. Now, Newton's second law, going to be the most common law that you use in your homework. You need to start out by doing a sum of forces. What that means is that you add forces that are all pointing in the same direction. You subtract forces that are pointing in the opposite direction. So in our little drag car picture here, the engine is applying a force of 130 newtons. There's a small drag force acting on this car that's only 12 newtons. But doing a sum of forces, we can figure out what the acceleration of this car is. So you always start by doing a sum of forces, add them all up, subtract the ones pointing in the other direction, and set that equal to mass times acceleration. So in our case here, the 130 newtons is in the positive direction minus the 12 newtons, and we plug in our mass. We find out that the acceleration of this car is 0.094 meters per second squared. Okay, not a huge force acting on this car, and that car is pretty heavy, 1,250 kilograms. You know, that's a fairly heavy object. All right, Newton's third law is probably the most misused law. Newton said that for every action there's an equal and opposite reaction. Okay, he's talking about forces here. Don't try to apply it to politics or anything like that. We're talking about forces. So we see two kids on skateboards here, and the girl is pushing on the boy. Well, at the same time, there's an equal and opposite force. So both kids move apart. They both experience the same force. Now, even though these forces are equal, that does not mean that the accelerations will be equal. If the boy is heavier, if he's more massive than the girl, his acceleration is going to be less because of Newton's second law. Okay, so these all work together. Now, sometimes these interaction pairs are obvious, as in this one. The boy pushes on the girl pushes on the boy. We can talk about the reaction force to that pretty easily. Sometimes they're a little difficult. Let me give you a tip. Start by stating what the action force is. The girl pushes on the boy. Then all you've got to do is switch the nouns. The boy pushes on the girl. In order to find the reaction force, just switch the two objects around. And this is true for every single type of force. This is true for contact forces like girls pushing on boys. This is true for non-contact forces like magnetism and gravity. This was probably the biggest of the three laws, because it says that every force, there's this equal one, whether you know about it or not. Whether it's obvious or not, it's always there. Alright, so that's Newton's three laws and a little bit about the man himself. It's time to get to work, and I'll see you in class, and I'll see you online.